Okay, welcome back to another video. In this video, we're going to be looking at graphing day 3. And what we're going to be doing in it is just learning how to graph two new functions that you maybe you probably haven't seen the graphs of before. Maybe you have in very rare circumstances, but you probably shouldn't have seen these yet. Um, the two graphs that we're going to look at dealing with today are absolute value graphs and then square root graphs, okay? Um, and we're going to just learn how to graph those and then kind of learn how to graph like transformations of those when we move them around, like left, right, up, down, stuff like that. So that's kind of what we're going to be doing today. Just kind of extending our use of graphing to a few new functions. Okay. Now first, before we actually graph absolute value, we just want to kind of talk about what does absolute value mean, what does it do, so that we make sure that we kind of understand that going into the actual graphing. So absolute value is something that you are using when you only want to have a positive number as your answer. Okay. um, this basically, the idea with absolute value is just in a case where like a negative answer doesn't make sense, you could flip the sign on the answer to be a positive number. And that's basically all that absolute value is. So some examples of some situations where you only use positive numbers, for instance, are like distance, um, counting things, right? You can't have a negative number of something, okay? Um, so distance counting, yeah, there's lots of situations where really only positive numbers make sense. And that's kind of why we introduce this notation of absolute value, is because sometimes we want to just, if we got a negative number, we just want to flip the sign around so that it's not negative anymore. It just makes sense in context to do that. So your symbol, when you're doing an absolute value over down here, it's just these bars. You just put bars with the number, and basically whatever the number is, you're just going to flip it so that it's a positive number. So like the absolute value of -3 is just going to be +3. Okay, we just undo the negative on there. That's how you do an absolute value. Absolute value of -7, what is that going to be? Well, it just gets rid of the negative, so it's positive. So basically, when you do an absolute value, it just takes in a number and then returns the positive version of the number. Okay. Um, if it's a negative, it's going to just flip the sign. Okay. Now that kind of leads us to an interesting idea. I'm going to move this around a little bit. If you if you're taking an absolute value, we did 2 examples so far of this, right? We found the absolute value of -3 was +3, and the absolute value of -7 was +7. But what would happen if you do the absolute value of a positive number? Well, a positive number is already positive, so it's just going to leave it the same, right? The absolute value of 4 is just +4. Okay, so negatives are the ones that get flipped with an absolute value. That's what these bars mean, right? And then a positive just stays the same. Okay. Um, let's look at a few more examples where there's maybe a few more operations going on. We have here the absolute value of 3 plus 2. Okay. Now, this kind of is an order of operations thing. Of what are you going to do first? Are you going to add these two numbers first, or are you going to do the absolute value? Well, you kind of will treat these bars, they kind of function like parentheses do. Um, if you add parentheses with 3 plus 2 instead of the bars, basically with this, we are going to do whatever is inside parentheses or inside the absolute value bars first, and then we'll do anything on the outside. So it's kind of like you do it in the same order as you would parentheses. So we're going to start by adding those two numbers. 3 plus 2 is 5. Okay. And then we're doing the absolute value of 5. Okay. Which is just 5, right? Because 5 is already positive. Okay. Let's try a few more of these just to kind of make sure we got it down. Let's look at absolute value of 5 minus 7. Okay. Close absolute values and then plus 1. Okay. So what are we going to do first with this? Do we flip the signs of both the 5 and the 7? Well, not quite. What we're going to do first is where those two are inside, kind of like with parentheses, you're going to do what's inside the parentheses first. So we're going to do 5 minus 7 first. That gives us negative 2. Okay, that whole part right there is just negative 2. It's still inside the absolute value. Okay, negative 2 plus 1. Okay. And then what are we going to do next? Well, we've got those absolute value bars. It's not around the 1, so we're going to do the absolute value on the negative 2 first, okay? So absolute value of negative 2 is positive 2. Okay, just flip the sign. And then 2 plus 1 is 3. Okay, so that would just be 3. Let's just do one more. We have here absolute value of 4 minus 3, okay? And then we're minusing 6 from that absolute value, okay? So what are you going to do first on this one? What operation will you do first? Well, we do the things inside the absolute value, kind of inside the parentheses, right? So inside these, we do 4 minus 3 is 1. Have to draw those kind of funky. That's a 1 inside of absolute values. Okay. And now the absolute values are only around the 1, so we're just going to do absolute value on that. We're going to do absolute value of positive 1. What does that give us? It's just positive 1 still. And then subtract 6, we get negative 5. Okay, so that would be our answer there. So that's kind of how you work with absolute values when there's more than just a number in there, kind of how you play around with them in that case. Okay, so that's an absolute value. Just takes negative numbers, makes them positive, takes positive numbers, leaves them the same. That's kind of the deal with absolute value. Okay. What we want to do now that we kind of know what this absolute value is we want to sketch a graph of what this is going to look like a y equals absolute value of x. What is that going to do on a graph? Okay, so that's going to be what we're going to do next, is kind of look at the graph of absolute value of x. Okay, so we have our function here, y equals absolute value of x, okay? And we want to sketch a graph of this. Well, let's start by making a table of values just so that we can plot some points on this graph, kind of get an idea of what's happening. Remember, when you have a table, right, this first column is the x values, and then the second column is the y values. So how do you get the y value when x is negative 3 here? How do you use this -3 to get the y value. You're just plugging x into this formula to get the y value, right? So we're replacing x with -3 here. So really we're just doing the absolute value of -3, okay? The absolute value of -3. We're just replacing x with -3 in there to get our y. Then we're going to figure out what that is, right? Absolute value of -3, what is that going to be? Well, it just flips the sign on it, so it's going to be +3, right? So when you plug in -3, you should get out +3, okay? Now you should be able to fill in kind of the rest of the table just off this, but let's go through that real quickly. When you do -2, we're going to do absolute value of -2, right? What's the absolute value of -2? It is +2, right? Just flip the sign. Absolute value of -1 is +1. Okay, let's plug in 0. Absolute value of 0 is, well, that one doesn't have a negative or a positive, so that one's not going to change. It doesn't really matter. That's just 0. And then let's plug in these other ones. Absolute value of +1 is, it doesn't change that one. It just leaves it positive, right? And then 2 is already positive, so it leaves that one the same. 3 is already positive, so it leaves that one the same, okay? So those are our y values for this table, okay? Now that we have that, we can kind of sketch a graph of what this is going to look like, okay? So we can go through these points. The x value was -3, y value is +3, so left 3, 1, 2, 3, and then up 3, 1, 2, 3. Right? Y is the vertical and x is the horizontal. Okay, let's keep plotting. -2 and 2. It's right there. Okay, -1 and 1. It's right there. 0, 0 is at the origin, right there. Okay, and then 1, 1. Then 2, 2. And then 3, 3. Up there, okay? So we're just plotting those points on our graph, okay? Now, what pattern do you see here? What do you think this graph is going to look like? Well, it kind of looks like on this side, right? It's kind of like a straight line going this way, right? So I imagine it's going to just keep going up, kind of like what it's doing right there. But then it reaches 0 and it kind of does something else, right? It starts going up this other way and it kind of looks like it just keeps going that way, kind of like that. So the graph, when you actually graph an absolute value, it's actually a V shape, okay? It's not a parabola. A parabola is kind of the U shape where it's rounded on the end. This one has a sharp corner down here at the bottom, and so this is an absolute value graph. Okay, it's kind of like a V. Okay, and of course we always have to put eyeballs on our graphs. That's not creepy at all. Okay, yeah. Sorry, now you have something to haunt your nightmares. Okay, so that's your basic absolute value graph. Let's do kind of a transformed one. I'm going to do another example here. And this will kind of be more similar to what you're doing on the homework. Okay. Now we want to sketch a graph of this guy right here, the absolute value of x minus 1 plus 4. Okay. Now it turns out you don't actually have to do a table on this one to figure out what the graph is. If you know what the basic absolute value graph looks like, it's that V, right, going through 0, 0, the V going through 0, 0, we can just move that around, okay? We can just move that around to get the graph of this one. Now, if you kind of remember from last time, we reviewed our graphing of parabolas, right? And parabolas have the square, right? It would be like y equals x minus 1 squared plus 4 would be kind of something similar in a parabola. Okay, that would be kind of the U shape for this graph. Now, what happened to the graph when you put these things in here, this 1 and this 4? Okay, how does that change our graph? Well, the 1 was moving us to the right one, right? It did the opposite because it was right there inside next to the x. And then the 4, this moved us up 4. So typically we had this like a parabola going through 0, 0, kind of like that. And then after we did put those two numbers in, it would just go right 1 and up 4. 1, 2, 3, 4. And so it would be another parabola just kind of going through that corner point like that, okay? The same idea is going to be true for this one right here. It's just instead of being a parabola like this one would be, it is going to be the V shape, which all absolute values are. So what is this 1 doing to our graph here? When you're minusing 1, you do the opposite of that because it's right in there next to the x. That's going to go, right 1. Okay, and then this plus 4 on the outside, it's not right next to the y, so that means we're going to go the same direction as it is. We're going to go up 4. Okay, so we're going to take our typical V-shaped graph and we're just going to move it right 1 and up 4. So usually our V starts at 0, 0 here, so we're just going to go right 1, and then up 1, 2, 3, 4. Okay, so right 1 and up 4, and that's going to be the new kind of corner to our V that we have, okay? And then basically where there's no number out in front here, where it's just, we didn't times it by anything to shrink it up. We'll do some examples of that later, but it's going to have the exact same shape as the other absolute value we just graphed, right? Which, if you kind of remember, I can show that here real fast. If we remember what that looked like, well, it was a V and then it was going over 1, up 1, or up 1, over 1, up 1, over 1, over here, right? And then it was just doing kind of the opposite over here. It was going down 1, over 1, down 1, over 1, okay? So that's kind of what it was doing. So it's going to do the same thing on this one that we're doing right now. It's going to go from the V, it's going to go up 1, over 1, up 1, over 1, up 1, over 1. It'll keep doing that same thing that way, okay? The other way, it will kind of do the same thing just backwards, right? Okay, so it will go down 1, over 1, right? Down 1, over 1, okay? Or if you kind of go backwards, if you go left 1, it would go up 1, right? So that would be the graph of this absolute value function, okay? It just got moved around, okay? So now that we have the graph, we can find domain and range, kind of like what we did last time. Remember, domain is the x values, so what x values can we plug in? Well, when we kind of project this down, just draw lines down to the x-axis, what gets hit? It's really everything on the x-axis. Any x value will have a point on the graph. So domain would be negative infinity to infinity, okay? And then your range, those are the y values that have points, right? The y values that are contained in the points on your graph. Well, that starts down here at the bottom and then it goes up onto infinity, right? So it starts down at, let's see, that's 1, 2, 3, 4, right? Up at 4. And then it goes all the way up to infinity, okay? So from 4 to infinity is the range. Those are the y values that we're using. We are including 4 because it's it starts out at 4, so there is a point with 4, and then it goes off to infinity. We don't include infinity. Okay, so that's our domain and range of this function. Okay, so actually this graphing the absolute value is very similar to graphing like a parabola like this x minus 1 squared plus 4. It's just there's the bars there. So it's going to be a V instead of the U shape that we were dealing with before. Okay? Let's just do a few more examples of this. Okay. Okay. So let's do a few examples. We have here the absolute value of x plus 1. Okay. So basically this is an absolute value, so it's going to be a V graph. The plus 1 in there, what is that going to do to our V graph? How is that going to move it? Well, it's inside next to the x, so it's affecting the x. That means we're going to go left or right. When it's right next to it, it's going to do the opposite. It's going to go left 1. Okay? And notice there's nothing out here. There's no like addition just on the outside. So this one, there's nothing else that's happening to the graph. It's just going left 1. Okay? So what that means, right, is typically the corner's at 0, 0 for just regular absolute value. So now it's going to be left 1. It's going to be at negative 1. Okay, is going to be the new corner. And then it's going to be the typical V shape. It's going to go up 1 over 1, up 1 over 1, like that. Okay, and then kind of mirror image on the other side. It's going to go up 1, left 1, up 1, left 1 on the other side to get your V shape. So that would be your absolute value graph for this one. Okay, it just goes left 1, so you just move the V to the left 1. Okay, let's find the domain and range. Domain of your function, those are the x values, right? What x values can we plug in? We're just projecting it down onto the x-axis. So everything over here works, everything over here works. It's anything, right? Negative infinity to infinity is your domain. And actually that will be true for any absolute value graph. The domain will be negative infinity to infinity. Let's look at the range. That one won't quite be though, because your absolute value is always that V, so it's always going to kind of have a bottom to the V. Kind of like the vertex of the quadratic. So what's the range of our function? Well, those are the y values. The y value at the bottom here is 0, right? The x value is negative 1, but the y value is 0, and then it goes up to infinity, right? All the y values are hit besides nothing down here is hit. So we just go from 0, we want to include 0, up to infinity, and that's our range. Okay? Okay, so that would be our graph and our domain and range. I want to do maybe just one more example of a regular absolute value without any weird numbers happening on the outside. So let's just do one more. We have absolute value of x minus 4 and then minus 4. The The -4 on the inside, what is that going to do to the graph? That moves us right 4 because it's inside with the x, so it's doing the opposite. The thing on the outside here tells us we're going to go down 4. Okay, so we're going to go right 4 and down 4. 1, 2, 3, 4, and then down 4. 1, 2, 3, 4. Remember, you only switch the sign on the inside one, not the outside one, right? Okay, so that's our new corner point, and then we just fill in the V, right? The V, we go up 1 over 1, up 1 over 1. Okay, that's one side of it. The other side is kind of just a mirror image. Now we go up 1, left 1, up 1, left 1. Like that. Okay, so that would be our graph for this function. Okay, what's the domain? Domain will be, again, -infinity to infinity, because all the x values will have a point on them, right? This will continue on off the graph, so all the horizontals get hit. The range, what y values get hit? Well, nothing below this point right here gets hit, so it's only things that have a y value of -4 and up that get hit. So from -4 up to infinity. Okay, that's our range. Okay, so that's graphing a absolute value function. Just you have to remember that the absolute value looks like the v, and then you're just kind of moving the v around. Okay. One other thing I want to mention before we move on to square roots is what would happen if you put a negative on the outside of the absolute value? What is that going to look like if you sketch a graph of that? Well, if you kind of remember, when we had y equals x squared, that was our like nice kind of parabola like that, okay? And then when you did negative x squared, okay, when you threw a negative out in front, what did the graph look like for that? It looked like upside down parabola, right? And so that is exactly what happens with this absolute value. Is typically the absolute value is a v, right? An upwards v. So when you got a negative out in front, it's just going to look like an upside down v. So that would kind of be your graph when there would be a negative out in front. Okay. Let's do one example like that, and then we'll do square roots after that. Okay. So let's do an example. So we have here this negative x plus 3 with the absolute values, and then -4. Okay. So what is the graph of this going to look like? Well, we already kind of talked about what the 3 and the -4 are doing, right? What does the 3 do? That moves us left 3 because it's a plus 3, so opposite of that. And then this one moves us down 4. Okay, that one moves us down 4. The 3 moves us left 3. But then that negative on the outside, what is that going to do? Well, that just flips it upside down. So basically, we're going to graph it the same as we would before. We're going to go left 3, 1, 2, 3, and then down 4, 1, 2, 3, 4. So right there, left 3 and down 4. It's just now, instead of having the V shape up like this, right, kind of like that, we want it to go upside down, right? We want it to be a downwards facing V. So it's going to go more like this. And it is going to go over 1, down 1 on both sides of the vertex. Okay, so that would be your graph on this one. Okay, let's just find domain and range real fast. Domain, again, is anything is going to work. Any horizontal point is gonna get hit. And then the range, what y values are hit, it's only from -4 down, right? -4 to -infinity, that's what's getting hit. Anything above -4 isn't going to work. So what we do, we usually start at the smaller number. We go from -infinity up to -4, and we do include -4. Okay. So that would be our range on that one. So again, this is not a U shape. This is a V. It has a sharp corner on this graph here. Okay? So that is your absolute value graph. It's just a V, or sometimes it's an upside down V if there's that negative out in front. Okay? I think that's all I want to do with absolute value. I think that's probably a sufficient number of examples. Okay, one last thing we're going to do today. The other function we want to look at graphing is a square root function. Okay, we've dealt with square roots a lot in this class up to this point, right? We've used them to solve quadratics and find missing sides of right triangles. Okay, so what we want to do now is we just have y equals the square root of x. We want to sketch a graph of what that's going to look like. Okay, now remember how we get kind of a graph. If we don't know what a graph looks like, you can always make a table and kind of plot the points to kind of see what it's going to look like. Once we plot this like y equals the square root of x, it's kind of a common graph that you should just know, and then you won't have to do a table of graphs or a table of points every time you have to graph a square root, because you'll kind of just know what it looks like. Now you certainly can, if you forget what it looks like, you can always plot points to find kind of what it looks like. Okay, let's go ahead and start with plugging in -1 for x, right? What do we do with this to find the y? We plug it into the equation, right? So it's square root of -1 is what we're doing here. We're just plugging in -1 into x. Now, I started us off with a little bit of a tricky one, okay? If you do the square root of -1 in the calculator, it's going to give you an error. And the reason for that, right, is we did talk about this a long time ago, but this is not a real number. This is actually an imaginary number. We sometimes called this number I, right? The square root of -1 was I, okay? Now, we can't graph I on this real graph that we have. So this point, this x value, we can't actually plug in to the function. It doesn't make sense. So this one just doesn't have a y value. We can't plug that in. Sorry, maybe I should do a red x. I'm putting this here because this one doesn't work. We can't plug in 1 and have that make sense. Okay, well, I mean, we can if we allow complex numbers, but that doesn't show up on the graph, so that is not going to make sense. Okay, let's try 0 now. 0 might be a little bit better. Square root of 0. Okay, we just plug in 0 for x. What is the square root of 0? Well, plug it in the calculator. It is 0, right? Because 0 squared gives you 0. So this is just 0. Okay. Now let's do 1. The square root of 1 is just equal to 1. Okay, because 1 squared is 1. That's just 1. Okay. Now let's do 2. Square root of 2. Now, if you do that in the calculator, you get like this big old nasty decimal number, okay? So that's kind of a pain. If you do square root of 2, you should get like 1.41. Oop, my pencil just broke. 1.41, and it keeps going. It's like a big nasty decimal, right? It's the number you have to square to get 2. Okay, so this is like 1.41. That's kind of nasty though. We don't like that that's a big old nasty decimal. Now, I do want us to think about what is one more point we could maybe find along this graph. I could plug in like 3 to find another point on the graph, but when I do the square root of 3, that again is going to be a really nasty decimal value for the point. What number can you plug in for x here to get a nice whole number? What's a number that you can take a square root of and get a really nice number? Well, there's a lot of possible answers, but one of them, probably the smallest one you could do for this, is 4, right? That's the next smallest perfect square. When you do the square root of 4, you get 2, right? Because 2 squared is 4. Okay, so that would give us a nice point. You could have also done 9. The square root of 9 is 3. Right? You could have also done 25 is 5, but we don't want it to get too big. So this is probably a good one to do. 4 and 2 is a good option. Okay, so let's plot our points. -1 didn't make sense, so it looks like we're at 0, 0 first. Okay, then we're at 1, 1. 2 was at a decimal. It was like 1.4, so kind of like part way there. And then 4 was at 2. 1, 2, 3, 4. We're up at 2. Okay, so you can kind of see what the graph is going to do based off those points we plotted. It looks like it's kind of a smooth curve. Okay, and what ends up happening here is you kind of get a sideways half parabola. Okay, so it's, remember, a parabola is kind of the U shape, right? This one doesn't have this kind of the other half of the parabola, but it's kind of like half of a parabola, and it's sideways. Okay, so that's your graph of y equals the square root of x. It starts out here at 0, 0, and then it's kind of that parabola shape. Okay, let's find the domain and range of this function real fast. Domain, notice the x values that work. We did find an x value that didn't work, right? Any negative number we can't take a square root of. There's no points over there on the graph. So it's only things for x that are 0 and bigger. So from 0 to infinity is our domain. And then our range is the y values, which again, that's only numbers that are positive here. That's from 0 to infinity. So that's our domain and range for this square root graph. Okay? Okay, I think that's it as far as just graphing the regular square root. Let's just do 1 or 2 examples here, and then we will be done for today. Okay, now that we graphed our basic square root, we can kind of sketch a graph of something like this, where it's kind of transformed. The rules for how the graph is changing is very similar to the absolute value and the parabola that we did before. So what do you think this +2 inside the square root right next to the x, what is that going to do? That's going to move us left 2. And then this 1 on the outside there, what is that going to do to the graph? That's going to move us down 1. Okay, so we're going to take our regular square root graph and just do left 2 and down 1. And that's going to be kind of our new graph. Okay, so remember our typical square root started at 0, 0. So we go left 2, 1, 2, and then down 1. That's where we start now. And then it was kind of a parabola, so it went over 1, up 1, right? But it was only half of 1, so it's kind of bent like that. Okay, and that's, you could find more points on this if you really want to. I really just want 2 points. So it starts out here at -2 and -1, and then goes up 1 over 1 like the regular square root graph does. And that's your graph. Okay, looks kind of like that. Okay, domain. Domain is the x values. Notice x values over here, right, don't work. It's only x values over here that make sense when we plug them in. So -2 is where it starts out to infinity. Those are the x values that make sense. Okay. Then the y values that make sense here, or that have points with them, is we start down here at y equals -1, and then it's everything above that, right? So from -1 up to infinity, and that's our domain and range. Okay, so that's how you would graph a square root function here. Okay. I'll just do one more example and then we'll be done here for today. Sorry, this has been a little bit of a longer video, but trying to give you lots of examples. Okay, let's look at this absolute, or sorry, not absolute value. Let's look at the square root of x minus 2. Okay, so again, how are we going to graph this? When you do the -2 inside there with the x, that's moving us left or right. It does opposite, so we go right 2. Okay, notice there's no other number on the outside here, so we don't go up or down at all. We just go right 2. Right 2. That's our kind of corner point, and then it's a sideways parabola. So up 1 over 1, and then it's kind of going like that. Again, that's not a perfect graph, but that's kind of what's happening there. Okay. Okay, domain. Domain is x values, so the x value starts at 2 and then goes on, right? So 2 to infinity is our domain, right? Those are the x values that work in here. And then the range, the y values that we get out are, well, it starts here, y is 0 here, and then it goes up, right? So from 0 to infinity is our range, okay? And that's our domain and range of our function, okay? So what did we do today again? We graphed absolute value and square root functions, and we found their domain and range. Okay, it's very similar to graphing parabolas, only an absolute value that looked like the V shape, and then the square root was kind of this sideways parabola shape. Okay, and only half of it. So, oh, sorry. I think that's it for today. I'll go ahead and stop the video here. Good luck on your homework, and I'll see you in the next video.